And then sharing my screen. Oops, wrong one. I hit the wrong share button. Some good lighting. Why is this? There it goes. Okay. So today I'm going over simplifying rational expressions, which is part of section P.5. Tomorrow, I did have to reschedule tomorrow's session to the afternoon from the evening because I have something added to my calendar in the evening. But that one will be on multiplying and dividing rational expressions. And then if I have time, depending on how long that takes, I might do some adding and subtracting because that's also difficult for people. We'll see how it goes. So first off, P.5. So P.5 covers domains of algebraic expressions, which is not just rational functions. So that's or rational expressions. So that's a little interesting because it has some things that are not rational expressions in that section. And then it goes on to simplifying rational expressions, adding and subtracting, multiplying and dividing rational expressions, and then simplifying complex fractions and difference quotients. So the last part here is usually needed for pre-calc. So if you're going on to pre-calc, you want to make sure that you take some time to make sure you do that stuff. But if you don't have to go on to pre-calculus, then that part is not as much of a big deal as the adding, subtracting, multiplying, dividing, and the simplifying parts. So what is a rational expression, basically? So a rational expression is an expression that contains fractions with variables in the denominator of the fraction. So some examples of rational expressions and non-rational expressions. So a rational expression would be something like 1 over x. So there's a variable in the denominator. Something non-rational would be like x over 2 because the denominator is an actual number, not a variable. So the key is that there's variables in the denominator, and that's what makes it a rational function. We can also have variables in the numerator as well. So you could have something like 2x plus 5 over x squared, and that is also something that's considered a rational expression. As long as the denominator has a variable, then it is rational. So in order to understand and work with rational expressions, especially with our particular textbook, we need to have some understanding of domain. So I'm going to go into domain on various types of expressions before we really go into the simplifying of rational expressions. So the domain of an expression is the set of real numbers for which it is defined. Domain is specific to the inputs or the x values. So think of it as the inputs, basically what you can plug into an expression. And it's basically, we think of the domain as the values that you're allowed to plug in and you don't come up with any errors or anything. And so determining domain does involve some critical thinking and some memorization. So if you have radicals, which means you have a square root, a cubed root, or something, the domain is all real numbers, so you can put anything in for x where that whatever's inside the square root is greater than or equal to 0 and solved for the variable. This actually is particular to even roots because we can't have negatives inside an even root. So whatever's inside there has to be greater than or equal to 0. And so we determine where that is and then solve for the variable. And solving for that variable, that is something we actually cover in 1.7. So you guys have not seen that yet. Polynomials, we've talked about polynomials. for polynomials, the domain is all real numbers. So that's when we basically just memorize. Every polynomial, the domain is all real numbers. And then rational expressions, the domain is all real numbers except where the denominator is 0. And that's because you can't divide by 0. If you divide by 0, you get undefined. And so any number, any value for x that makes the denominator 0 gives us undefined, and so we can't plug that number in. And so those are excluded from the domain. And that's the part that we really have to talk about domain because of rational expressions, because we have to take that into account. So I've got 3 examples here, finding the domain of the expression. So the first one, we have 6x squared minus 9. So this is a polynomial. And polynomials, their domain is all real numbers. Except in this case, they tell us x has to be greater than 0. So because they're telling us that, that means our domain is x greater than 0. Because they're specifying that we're not including the negative numbers here. So what that means is we can only plug positive numbers into 6x squared minus 9 for this particular expression they've given us. The second one here is a rational expression where the denominator has a variable. So the domain is everywhere except for where the denominator is 0. So this is a rational expression. And so what you do is you take your denominator, and that cannot equal 0 because then we're dividing by 0. And so you ask yourself, what number will make that 0? So if x is negative 5, we'd have negative 5 plus 5, which would be 0. So x cannot equal negative 5 because that will make that 0, and it's not allowed to be 0. So our domain is basically all numbers except negative 5. And you can actually, there's a nice little trick. The not equals is just like solving. And we haven't technically learned about solving yet because that's in section 1.2, but it's assumed you've had some experience with that coming in. Where if I subtract 5 from both sides, that's how I get x is not equal to negative 5. So this is technically a little bit from 1.2, and while it's not in the prerequisite section, it is presumed that you have a little experience with solving for x. The last one here, we've got the square root of 2x minus 5. So this is a radical, and it has an even exponent, which means whatever is inside there needs to be greater than or equal to 0 in order for us to get an answer out. And so you can do this by looking at the graph and looking at what values are allowed or what values you have it graphed over. Or I'm going to actually show you a little bit of 1.7 here. So you have a little preview of 1.7. We solve this just like you would solve for x. So it's actually a little bit of 1.2 as well. So when we're solving, we start by adding 5 to both sides because we want the x by itself. So that gives us 2x is greater than or equal to 5. And then you divide both sides by 2 to get just x. And that gives you x is greater than or equal to 5 halves. So our domain is x greater than or equal to 5 over 2. And if you look at a graph of this, what that means is that you will only have a graph that is for values of x greater than 5 halves. So I'm actually going to bring that up so you can see that. So I'm going to bring up Desmos. And I'm going to put in the square root of 2x minus 5. So x is our horizontal. Now this is, this graphing part is technically something in p.6, but it's assumed you've kind of had some experience with graphing before. So 5 halves is 2.5. So you can see for x values, that's the horizontal, that are equal to 5 halves or greater, we have our graph. But for any values smaller than that, we don't have anything graphed. So the domain is basically where do you have something graphed? And we have, our graph is present at 5 halves and larger. And you can zoom out, we can click and scroll, and it just keeps going on forever. So that's basics for domain, and that's how you can use the graph to kind of reinforce finding the domain and everything. But these solving things, we'll see those more when we get to 1.2 and 1.7. These pop up, they talk about it in this section a little bit, even though you kind of need some other information to really fully understand it. So it's a little interesting the way that the book organizes these things. But that's just an example of domain. But what we care about really are the rational expressions, and so we care about basically where the denominator is equal to 0. So don't worry too much about this because you will see it again next week. Okay, so now simplifying rational expressions. So we have something, a rational expression with fractions. And to simplify this, it means you need to factor, and then you cancel out common factors. So that's one of the reasons why factoring is so important, because it is needed for things that follow. And so factoring was p.4. So if you need additional help on that, go to p.4. I do have my video that I did yesterday on factoring. And then I also have linked here 3 additional links about factoring. So if you need some additional help with factoring, check out those links as well. And before we even get to any examples, now I need to connect the domain to the simplifying rational expressions thing. So our textbook, what it does is a little different than other textbooks I've seen, but it requires you to indicate the domain if you're doing any simplifying of rational expressions, which is p.5. And so when you go to a quiz, like for next week's quiz, you'll see it's multiple choice, and you'll see though there will be restrictions, like x is not equal to, x equals not equal 5, and you might have the same simplified expression but different domains there. So that's why it's important to understand how to find the domain, so you know which of the two is the correct answer, because the simplified part might look exactly the same. So the whole reason why the book wants you to indicate the domain is because when we cancel out common factors, we're basically dividing them out from the top and the bottom. And because we're dividing them, you can't divide by 0. And so we have to make sure that whatever we divide out, that's not 0. So you have to specify that whatever you just removed, the x value, what x values make that 0 are not allowed, because then you're dividing by 0 and you can't do that. So that's the general rule. And so the way the book does it is it basically takes the original expression you're given and the domain there, and then if you cancel something out and your domain is different in the simplified version, you have to specify the domain of whatever was missing. So this will make much more sense when you see this worked out. Okay, so it says, so I've got 2 examples here to start. Write the rational expression in simplest form. The first one here is actually something we saw in p.2. It's an exponential expression. So we saw things with exponents, we call them exponential expressions, but it's also technically a rational expression because we have a variable in the denominator. And so we can simplify this like we would simplify any other exponential expression. But what's different here is when we're considering it as a rational function, we have to consider what values make the denominator 0. So here I have 60y to the 5th. So I can't plug in 0 for y because then I have 60 times 0 and I get 0 in the denominator. So y cannot equal 0. So we have to keep that in mind when we're simplifying. And if we end up having no y's left or something like that in the end, we may have to write that. So I've got my rational expression. And the first thing that I do is reduce the fractions. I've got 18 and 60. And I may not reduce it the smartest way. I just reduce it by the first numbers that I see that I know go into it. So I know that 6 goes into 18 and 6 goes into 60. So I'm going to just make a little note to myself and I'm going to divide each of those by 6. So 18 divided by 6 is 3. 60 divided by 6 is 10. So I know I have 3 over 10. Now for the variables, when we have an exponential expression, you subtract the exponents 2 minus 5 is top minus bottom. So there's going to be y to the 2 minus 5, which is negative 3. And then if I have a negative exponent, I need to get rid of that negative exponent by taking the reciprocal. And so that will actually put it in the denominator. And we end up with 3 over 10y to the 3rd. So that's the simplest form. That's basically just a review of p.2. And we don't need to restate the domain because we are still not allowed to have 0 in the denominator here. We didn't remove, it's still the same. So here we got y not equal to 0. So it hasn't changed from the beginning. So we don't have to mention the domain in this case. Now I'm going to look at the second example, and this is what we consider more traditional rational expression, where you actually have things added and subtracted. You basically have polynomials on the top and the bottom. And to do that, we need a factor. So I'm going to just label this then. Now this is something more, this is a p.5 kind of problem. So first off, I'm going to rearrange my top, the numerator, so that I have negative 4x plus 12. And I do that just because when we work with rational expressions, you want to always be decreasing in powers, or so you have your variables first and then your constants are last. So I have negative 4x plus 12 over x minus 3. And now I want to factor. And so this is why being able to factor quickly is helpful, because otherwise you have a lot of steps that you're writing down. So the numerator, 4 and 12, I can factor out of 4. Because I have a negative in the front, I'm going to factor out a negative 4. So I'm going to then divide out a negative 4 from negative 4x plus 12. So that will leave me x minus 3. Because 12 divided by negative 4 is a negative 3. In the denominator here, I still have x minus 3. And there's nothing to factor out because the only thing in common between the x and a 3 is just 1. Now we want to cancel out common factors. So I'm going to highlight here that the x minus 3 is on the top and the bottom, and we can basically cancel those out. So this is very similar to what we did with factoring. The exponents in each of those would be 1. 1 minus 1 is 0. They're gone. And so our answer here results in negative 4 because everything else basically canceled out. Now, here's the thing that we have to consider, and that's the domain. So in our original problem, x minus 3 cannot be 0, which means that x can't be 3 because 3 minus 3 is 0. that has to carry down to our answer because we divided everything by an x minus 3. We basically removed it, and we don't have any variables left. So this is the part that the book is very particular about, that whatever we canceled out, the x minus 3, we have to make sure we specify that this simplifies to -4 for everything except x equals 3. Because that was not allowed in our original problem, and so it's still not allowed in the simplified part, even though we don't have any x's at all. So are there any questions so far? Okay. Terribly confused. Okay. Well, what are you confused about? Where is the first part that you're confused about? Because if I can clear it up now, that would be.
I don't want to shorten your speech. I will probably have to go back and look at it, but I think from the times from the original paid and expressions and the stuff off to the side, I'm just on cruise control right now, so it's just best that I kind of listen. Maybe it'll catch up with me. I don't even know where to start.
Okay. Is it mostly the domain part you're confused about, or the actual, like, the simplifying part?
Simplifying, I think I got. I think it's just the domain portions of it.
Okay.
When you get into your factors, how you said like the -4 minus the x not equal to the 3 and all that stuff. I think I'm understanding, but it's just I'm not sure how to formulate the question. So maybe if I see a few more of your examples, I may understand.
Okay. I'll do another one, and then I'll check in again. Okay. So I've got a couple more examples here. I may actually have to split these up into 2 separate screens because I may run out of room. Okay. So we're doing the same thing. We're simplifying. So maybe let me start off with the domain before I start simplifying. So maybe that will help. So on the left, we have x squared minus 5 over 5 minus x. So our denominator of the fraction, we cannot have that equal to 0 because then we're dividing by 0. So that's what gives me 5 minus x is not equal to 0. And let me make a better not equal sign. And then I ask myself, what number, if I plugged into x, does make that 0? Because that's the number I'm not allowed to plug in for x. Another way to look at it is that you're actually solving that equation for x, which means you're trying to get x by itself. So in this case, the solving process, which we haven't technically really learned, but you'd be adding x to both sides of the equation so that the x's cancel out on the left. And then that would be left with 5 is not equal to x. So if I plug in 5 for x in the denominator, I would get 5 minus 5, which is 0. That would mean I'm dividing by 0, which I can't do. So that means I can plug in any number for x except 5, because then that causes a problem. So that's why in our domain, we're allowed to have any number except for 5, and that's where the x not equal 5 comes from. Does that make sense? Okay, good. Let's start by step by step. So now we don't have to care about that part until we get to the very end. So we just do that off to the side, and then that comes back in again after we've simplified. So I'm going to do what I did or in the previous example, where in our denominator, I want to put that x first. So I'm going to start by rewriting it. So I have x squared minus 25, and then I have to make sure my signs match up, so that becomes a negative x plus 5. Once I've rewritten that, now I need to factor. Now I'm not going to show all of the factoring steps since I did a whole video on that. But the first one, the x squared minus 25, that is a difference of 2 squares when it factors. That's one of our special ones. And that will factor to x plus 5 x minus 5. And the order there doesn't matter that you write them. The denominator here, it doesn't factor like a binomial because we don't have an x squared, so I just look at a greatest common factor. And I don't have numbers in common between an x and a 5, or like I can't take out an x, but because I have a negative in front of my x, I do want to factor out a negative 1. So I'm going to write down my greatest common factor, which is negative 1, and then I'm going to divide each part by negative 1, which basically changes the signs so that I have negative 1 times x minus 5. And now I look to see what cancels out, what matches on the top and the bottom. If it matches, then it disappears. And then we're left with whatever's left over. That negative 1 we usually just put in front because dividing by a negative is the same as multiplying by a negative. If there was a different number there, then we would have a fraction, but 1, it doesn't really matter. And then I'm left with x plus 5 because everything else canceled out. Now I have to go back because I canceled out the denominator and that was part of the domain. I have to stick that back in, the fact that x cannot equal 5. Because that was what happened, that relates to what we canceled out. So this x not equal 5, that comes from the x minus 5, which that x minus 5 part basically came from the negative x plus 5 part. And then all goes back to our domain. Because if I have x minus 5, 5 minus 5 is 0, we can't have that. And so if we put in 5 for x, we're dividing by 0. And so I have to specify that I can't plug 5 in because the original function didn't allow that number. Even though I can put 5 into our answer here, if I plug in 5, I get 5 plus 5, which is 10. I get negative 10. That's okay, but it all depends on what was not allowed in the original that we started with. And so because we originally started with something that does not allow 5, we are still not allowed to have 5 in the end, even if it does give us a number. Does that make sense? Okay, I see exclamation point, so hopefully that means that what your question was for the previous has cleared up this time. Sometimes it's like, let's try to explain it a different way. Are there other questions on this example? Okay, I'm going to switch to a different color for the second example just so that we don't get confused with these. Okay. The second one that I have here is more common. This is like what you're going to see a lot, especially on the practice. And so we have a trinomial on the top and the bottom. I don't have to rewrite anything because it goes from x squared to x to something without x. So the order from highest to lowest as far as exponents goes is fine. So the first thing you want to do is factor, and you need to factor the top and the bottom. And so I basically, both of these, because there's no number in front of the x squared, I would just be doing guessing and checking here for factoring. If you are someone who is not yet at that point where you can factor quickly, what I recommend you do before is to, let's see, I'll just kind of demonstrate how I would organize this first. So I would just have something labeled top, and then bottom. And then I would do the factoring for each of those separately, go through those, and then stick them together. So that would be especially helpful if you're going to use the AC method to factor, because there's a lot of steps involved. So if you just factor them separately and then combine them. So For the top here, I've got x squared plus 4x minus 5. So I know that I have to have an x times an x. I know I have to have two numbers that multiply to -5 and add to 4. Because I'm multiplying to a negative but adding to a positive, I know I have to have opposite signs because that's the only way to multiply to a negative. And I know the largest number has to be positive because the inside part is positive. The 4x is positive. So there's only two numbers that multiply to 5, 1 and 5. And if I do -1 times 5, that gets me -5. -1 plus 5 gives me 4. So that's going to be x minus 1, x plus 5. Or you could do x plus 5, x minus 1, either one. Now, I'm going to factor the bottom. This one is another one where I would basically do guessing and checking, sort of mentally in my head. And I'm looking for two numbers that multiply to 15 and add to 8. Because I'm multiplying to a positive, adding to a positive, they're all going to be positive. So to multiply to 15, I've got 1 times 15, which adds to 16, or 3 times 5, which adds to 8. So that means I have x plus 3, x plus 5. So if you need help organizing, do the top and the bottom factoring separately and show all the steps that you need to do, and then bring it together back into the rational expression. So I take my top, which is x minus 1, x plus 5, over the bottom, which is x plus 3, x plus 5. Now, if you're wondering why I didn't do the domain, like I started with the first one, it's because you can't really figure out the domain until you're factored. So the top, it was easy enough to figure out the domain because 5 minus x, it's easy to figure out what number makes that 0. But if you're looking at x squared plus 8x plus 15, figuring out what number makes that 0 is a lot harder to do mentally. And so you want to factor. And so now on my to figure out the domain, I look at my denominator of x plus 3 and x plus 5. So this is going to give me two numbers that I am not allowed to have be equal to 0, or two parts that can't be 0, because there's two different parts in the denominator. So the x plus 3 can't be equal to 0, and the x plus 5 can't be equal to 0. So for x plus 3, -3 plus 3 is 0, so that means x cannot equal -3. And then for x plus 5, -5 plus 5 is 0, so that means x cannot equal to -5. So for the original expression, we've got two numbers we're not allowed to have, or they make the denominator 0. So now that I've got that, now I'm going to start canceling. I'm going to see what cancels. And I can cancel out an x plus 5. So I have it on the top and on the bottom. So this would leave me with x minus 1 over x plus 3. Now, -3 is still not allowed because I have x plus 3. That is still there, so I don't have to write that part of the domain again because it's still in my expression when I ended. But I removed the x plus 5. So the domain part that matched up with the x plus 5, which disappeared, I have to write that part because that has disappeared. You wouldn't know from the simplified version that originally you were not allowed to have -5. So because I divided that out, and I have to make sure what I divided it out was not 0, I have to make sure I specify that. And so because the x plus 3 is still there, I didn't have to write that one, but I did have to write the part that got divided out. Does that make sense? Okay. This one went a lot quicker than I thought it was going to, based off of how long The factoring one took me. Do you want to see more examples? I can come up with more examples.
Yes, if you don't mind. Could you do more like the very last one? Maybe like
Sure.
1 or 2
Let
more.
me grab the textbook and see what I can pick out. Ooh, this one looks good. Okay. So this is number 29 in P.5. So this is actually an odd. No, let's do number 30 because that one's an even. So that way you still have the odd if you want to practice. So this is x squared minus 1 over x cubed plus x squared plus 9x plus 9. So I've got 2 terms in the front or at the top, 4 in the bottom. And if I have 4 in the bottom, that means we have to use grouping. So this is where doing them separately, like a top and a bottom, would really help you for organizing. So I'm going to just do these separately. Okay, so factoring the top, we have x squared minus 1. So this is one of the special products. This is difference of 2 squares again. And so that one factors to x plus 1, x minus 1. And being able to recognize that will really save you some time when you're factoring. Now, the denominator here, I need to do this by grouping because I have 4 terms. And so this is going to actually be a lot more work to show, which is why it's almost best to do the factoring separately. So I need to determine the GCF out of each pair before I can continue factoring. So the first pair I have x cubed and x squared. Smallest exponent is our GCF, so that's x squared. Second pair of 9x and 9, so I can factor out a 9 there. That's fairly obvious because both numbers have 9. So I'm going to show all of the steps here just to get that factoring by grouping process down. So you have your GCF in front, and then you divide each term by the GCF. And you do the same thing for the second set of parentheses. So then I've got my x squared. So x cubed over x squared, 3 minus 2 is 1. So I have a single x. X squared divided by x squared is 1. So I end up with an x plus 1. Then I have plus 9. And when I divide everything by 9, I get x plus 1. And now that the inside of my parentheses are the same, that's going to be my first group, x plus 1, or the first factor. And then x squared plus 9 is the second factor. Whenever you get something squared, you should always double check to see if that can be factored. X squared plus 9 cannot be factored. If it was x squared minus 9, we could factor that further because that would be a difference of 2 squares. But with the plus there, that can't factor. So that doesn't go any further. So now that I've done that, kind of off to the side, I can rewrite my expression in factored form and then determine the domain. So the domain comes from the denominator, and we have 2 pieces here. So I know that x plus 1 cannot equal to 0. And that means if I plug in negative 1, that makes it 0. So x cannot be negative 1. The second part, x squared plus 9, not equal to 0. So I'm going to just show you, if we go through the solving process, this is going to use this. I said that domain requires some critical thinking. Here's going to be, you're going to be doing some thinking here. If I subtract 9 to both sides, I get x squared cannot equal negative 9. So we need to think about what numbers could we put in for x that when you square gets you a negative. And well, that's not possible, because when you square a number, you always get a positive, because multiplying two negatives is a positive. So there's no way to get a negative number out when you square a positive. So that doesn't really give us anything part of the domain. It doesn't matter. And so that's not really considered a restriction, because it doesn't actually tell you any values of x that can't happen, because that situation, x squared, is always not equal to negative 9, because it's always going to be positive. So that's where you get some critical thinking, because you have to think about, well, what does this mean? What values of x will make this 0? And for that particular factor, nothing makes it 0. So it doesn't matter, because you're always going to get something that's positive. Are you with me with that explanation there? Okay, good. So you got to think through these things, because it's like, oh, wait a minute. So that means the only restriction we have is x not equal to negative 1. So now I'm going to just cancel out. And I just like to do this with highlighting, because it's really easy to see what you've canceled out, which is the x plus 1 on the top and the bottom. And so that leaves us, oh, let me make this back purple. X minus 1 on top, and then x squared plus 9 in the denominator. And because we removed the x plus 1 part, that's the part that we have to grab from our domain to put that back in. And that's the x not equal negative 1 that matches with that. Does that make sense? Are there any questions on that? Okay. Austin, do you have any questions?
No, ma'am. Thank you.
Okay. Do you guys want another example?
I'll never tell you to stop giving examples. Let's be clear, but I understand. If you have to go, I'll be sad, but I understand.
I'm looking in the book right now, and that the book doesn't have any additional examples, but tomorrow's session on multiplying and dividing, we always have to do the same simplifying process. So tomorrow you'll see more examples of this. It's just going to be like one extra step, essentially. So, but I've actually gone through all of the evens that the book gives. It only gives a few examples of each one. So if you think you guys are okay, then tomorrow you'll see more of this with the multiplying and the dividing part.
Yes, ma'am.
So, does that sound like a good trade-off, or? Because otherwise, if I try to come up with examples on my own, like make them up, I'm probably going to come up with things that don't factor. It's really hard to make up good math problems that work out nicely. So,
and I'll keep this brief. I noticed when I was doing some of these exercises yesterday between Khan University, or I might be in another website, like you were saying, there's so many different ways of doing it, and I caught myself getting confused looking at different ways of doing it. So I said, I like the way that you're teaching it. I want to kind of stick with something simple relatively, because you've taken some of those steps out to make it simple for us. Thank you.
right, yeah. Yeah, I try to, I mean, there's lots of different ways to do these things. And if you find one way that works for you and you keep doing that one way, then you should be fine, you know, as long as you just know that there are different methods, but as long as you get the same answer, generally you are okay. What I recommend doing is writing down, like keeping a cheat sheet and writing down the steps. So that if you forget how to factor and then you forget the forms and which one you do like guessing and checking or which one is the AC method, like make a cheat sheet and say factor and then write down the form and say here are the steps for this type. Here are the steps for this type. Or like here for simplifying, you would say 1, factor. 2, find the domain. 3, cancel things out. 4, see what part of the domain is missing. You know, you can do it, break it down step by step. That way when you go back, you have that procedure there that you can always refer to help you through. So, if you guys don't have any other questions, are you both of you guys able to, let's see, the one that I had rescheduled tomorrow is actually, I rescheduled at 2 o'clock because of the way my meetings fell. So I don't know if you guys are able to make that or if that one's going to be one where I just talk to myself and then I just record it. Are both of you guys able to make the 2 o'clock one? It's 2 o'clock Central Time.
I will not be able to because I'll be able to.
Okay. Yeah, see, that's the thing. It's like sometimes that's why it's kind of hard during the day, but like something came up in the evening and I'm like, oh, now I got to reschedule. Well, there will be a recording which I'll post, you know, as soon as I can afterwards. So even if you are working during that, you'll at least be able to ask or see the recording and then ask me questions about it later. I've had some people just take like screenshots from the recording or something and they send it to me and they're like, can you explain what you did here? And that works. So thank you guys for joining. Hopefully this will help you out for the rest of the problems, at least for the rest of the, I've covered almost every single thing that is on most of the hard parts that are on the assignment. So hopefully everybody at this point has enough to do most of the assignment.
So I got a quick question for you. So if whenever we watch a video and we have a question, like, could you please, I guess, reiterate this? Should we just email you that, like that screenshot and that question?
Yes, yeah, and because I'm uploading them on YouTube, I think if you're watching it directly on YouTube, like if you actually click the link to go to the YouTube page, if you leave a comment, I think it might save where you leave the comment, so that might also link you to, you know, the actual thing. But if you don't want to leave public comments or YouTube or anything, yeah, taking a screenshot or even giving me the timestamp of the video would help too, just to let me know at what part are you having questions.
Okay, thank you.
You're welcome. Anything else?
Question just outside of the class, really quick. The assignments, does that get turned in as well?
No.
Okay.
So you don't have to turn those in because, well, they're all odd problems, so all the answers are available. So that's why we don't bother having you turn those in. That's just to make sure you have enough practice to ramp you up to the assignment. And then that way you know you can check your answers before you, rather than just doing something and then hoping you're right when you turn it in.
No problem. Just learning that whole radical thing on the Word document. It's intense, but I'm getting it slowly.
Yes, and I do accept handwritten work as well. So I'm going to actually open it up. So I downloaded on my phone something called Cam Scanner. So it's an app on your phone. Oh, I should turn on I forgot that I turned my video off when I was doing the presentation. That would help. Okay, so it's a free app. You can pay for more stuff, but you don't have to. So Cam Scanner, this phone app, I think it's available on everything. Oh, this really wants me to subscribe. No, I don't want to subscribe. Go away. Okay, and so it just opens up this thing where you can take pictures of your documents. So to start, you hit the camera button there. So I'm going to just hit that, and then you basically take pictures of whatever paper you want to turn in. So I will just take a picture of something. And then you get a picture, and it actually allows you to crop it if you want to crop it. And so you then hit like a checkbox here. So we check that, and that cropped it and then turned it into black and white for me, but you don't have to do that or whatever. You can keep it in color. Hit the checkbox again for any edits. And then you just keep taking pictures of each page that you want to add. So let me take a picture of, I'll take a picture of the textbook this time. And then crop, we'll just keep it in color. And so when you take pictures and pages are in order, you've got this series of images, and it will create them into one document. There's a little button up here that says PDF. So you hit that button, and then it will create a PDF file where they're all your images are in order. So I then hit share. And so when you're on your phone, you have to share it somewhere. So a lot of people are like, well, what do I do with the image? You know, what do I do with that file afterwards? So you could share it to Gmail and then email it to yourself, and that way you have it on a computer so you can upload that image. Otherwise, you can save it to Google Drive, because I also have Google Drive on my phone, so I could save it to Google Drive and then download it from there. I have Dropbox, so that's another way. And that way then you can have it in an email, you can download the file and then upload that file to Blackboard for your submission, and you just have a single file versus like tons of images. So I recommend accessing that. Actually, if you can even do OneNote, you can save it to OneNote or OneDrive, any sort of thing where you have a place to store documents from your phone. So if you don't like typing things up, especially with radicals, that's an option. It takes a little bit getting used to that app, but it does create a nice PDF, and then you have a single file that you can upload.
Yes, ma'am. Your spreadsheet that you put in for each assignment, that worked out a lot. I think it's just a matter of, it makes it nice and clear. So it's actually helped me somewhat. So thank you.
That's good. Yeah, if I had a choice between like trying to decipher someone's handwriting or having them type it, I much prefer typed, because it's just, you know, if I have to guess at your handwriting, often I'll guess incorrectly. So I don't, you know, it's best to not have to worry about that. So anything else? All right. Well, if you guys have questions, of course, you can always email me or give me a call. I'm going to be in the office for the next hour and a half or so, and then I'm going to go home and start running all my errands and stuff. But I do have office hours tonight, so I'll be on the computer again later this evening if you have more questions and you email me. So thank you guys for coming. I hope you guys enjoy your Monday, and I will talk to you later. Bye.